Welcome back to Odyssey Codes. For today, I thought actually it would be a good idea for us to go a bit deeper into the tools that we'll be using, specifically IntelliJ. For many of you, you might use IntelliJ quite a bit, or you may not use IntelliJ at all. And I thought it would be a good idea to deep dive into that tool before we get into core programming concepts, just because I always find it easier to work on things when I understood the tools that I was using. So we'll cover why I use IntelliJ, why I believe it's a very important toolkit to have, or why it's important to have an IDE in your toolkit, one that you know well. And some developers choose not to focus on which tool they use or which IDE they use. But I found it really beneficial for myself to master two or three different IDEs just for different tasks and for me to move quickly in different tasks. So when it comes to the core programming work, I mostly work in IntelliJ. And as I mentioned earlier, this is a free IDE, but there is a paid version with a lot of other features that we'll cover later. But for now, we'll stick with the free version. It's really accessible. All you have to do is download it off of their website. And after you download it, you just open it and you can start a project. So here you can see I've already started a project, and it's a Maven-based project. So there will be a POM file. And we'll cover what a POM file is when we do a deep dive of this POM file. But just for now, all you need to understand is that this is where all of our dependencies or other large pieces of software are referenced. So we will be able to use them in our project. We also define core things like the Java version, so I can change the Java version I'm using from 11 to 17. But for right now, I like using Java 11 because it's rather stable. It's what you mostly use in production environments. And by production environments, I mean for when you go on a website, the live code that you're interacting with, that is production. So there's usually multiple stages of software development lifecycle. And the final stage is usually when the code goes into production and millions of people use what you've worked on. So that's actually one of the things that we'll try to do with this project. We'll try to build it from scratch. Like you can see, this is just a Hello World application. And we'll try to get to a point where we can deploy this and have as many people who would like to use this application or this service as much as they want to. And we'll talk about scaling and how you scale and after you build your application. And there's a plethora of things that we will talk about. But yeah, that is the POM file. The next important location is your tests. So this project, and it's pretty standard for Maven-based Java projects, for there to be a source directory, a main, and then inside of main, Java and a resources directory. And for those of you who are uninitiated, directories are what folders are called in Unix. Even though I'm on a Windows machine right now, I'll still be using a lot of Unix terminology just because it's what is common in the tech world. And later on, when we explore the Bash terminal or the terminal, we'll mostly be using those concepts in order to understand how we move around. But for now, yeah, so this is the source, the main, Java, and resources. And then the other really important one within source is test, where all of our tests go. It follows the same structure as the main, as the code that's in Java. Like you can see here, they're parallel. And you can see IntelliJ, one of the things that it does really well is that it color codes the two different locations. So we'll see that our tests are in the green, while the source code that we will be testing and interacting with later, and the code that runs is under the blue. And then after that, we have packages, and these packages is where all of our code will live. So like we covered last time, there are models. and our models are essentially going to be plain old Java objects, or POJOs, as we'll call them. And they're essentially going to model the structure for the project. So, for example, when we open up this class, we'll see that it basically models what a greeting is, and a greeting um, has an ID, content, and that's really about it. And a couple of getters and setters. Well, we have just getters here. But something really cool with Intellij is that you can actually generate code for you. So you can see here the getter, but if we need to generate like a setter or anything like that, we can as well. It will even generate our constructor for us. But yeah, you can see that it also highlights brackets for us, which makes it really easy. And something that I showcased last time is that you can actually hover over different objects, and you can see, for example, strings is one of the basic types in all programming languages. You'll see that in Java, a string is a class that implements all of these interfaces. And a string is also comprised of multiple primitive types. For example, bytes are a primitive type, integers or ints are a primitive type, and these are not to be confused with capital integer. And we'll talk about the difference. Then there is Boolean, longs, and a few other base types. But if you wanted to understand what a string was in Java and how it was represented in Java, you can actually go into the implementation and look at what a string actually is in Java. And this is the string object. The next thing I really enjoy about IntelliJ is the ability to run the application. So in Java, basic Java is that you always have to have a public static void main method. Each of these themselves are keywords, and they each mean something different. Like this means that this method is publicly accessible. Static means that every instance of this class essentially uses the same method. And void is a very funny type. It's also a type, and it means essentially this method returns nothing, or it returns void. So if we wanted it to return, the main method doesn't usually return anything, and it's always public static void. Um, it's pretty much always public static void, and we can run the application from this method. And you can see here that we're parsing the code, and it starts up this Spring application. So one of the tools that I'm also using is called Spring to make it easier for us to write an API and develop rather quickly. You can see we're starting the Spring application, and the Spring application is a booktube application. There are some annotations up here. I will talk about annotation processing in Java, which is something, it's a very advanced concept. You can actually make your own annotations. And later on, when we add, for example, Lombok, which is another tool, it'll show us, it'll help us reduce the amount of boilerplate code that we have to write. Because every time you create a POJO or plain old Java object, you don't really want to write the getters or setters. I actually wonder. Yeah, I already have this library, so actually I can do something like this, where these annotations will just automatically generate the getters and setters for me. So I don't really need that. And I also add another annotation called builder. that will allow us to build this greeting object. So what I mean by that is if we go to here, we can actually create a greeting, hello equals greeting.builder.build. And this is using a pattern, essentially a builder pattern. So what we'll do is we'll set an ID, and it's a long, so 5L, and then we'll put some context, and the content will be hello. So all we want is this greeting to essentially be hello. And for sake of this, what we're going to do, let's not start up the Spring application. Let's print hello dot, let's get the content. So essentially what I'm doing here is I'll be printing out the greeting. And then we can also say this, many times. We'll use the greeting.id. And you can see, if we jump into here, we never really defined hello, or like we never really defined the ID or the get content, right? We never defined get ID or get content. But looking at this application, you can see that we actually have access to these methods because they're just standard getters and setters, and those are taken care of by these two annotations. So now if I run this application, actually I'll run it in debug mode so we can look at what's happening line by line, so we can get a clearer picture of what is actually happening. And there are a lot of really powerful things that are happening in these few lines, especially when it comes to annotations, the builder pattern, creating an object, because something else that we can do is greeting by equals new greeting. So in Java, there are multiple ways to create objects, and what you're seeing are two different ways of doing that. So here you can see you pass in an ID and then by. So here we introduced a new keyword, the new keyword. And essentially what we're doing is creating a new greeting object that has the ID of 1 and the content of by. So now when I run this in debug mode, which is another really important feature in Intellij, that allows us to look at line by line and look at the output of, look at the value of the objects at runtime. So you can see here we have a by, which is a greeting, and inside of that by is the ID 1 and the content by, and you see ID is an int and content is a string. And then after that we have our greeting, our hello object, and you can see it's also in line. And it looks rather similar to the by object with the ID and the content, the ID and the content. And now we're going to print out into the logs. And you can see here I'm using IntelliJ's core debugging features. So I'm stepping through line by line. If I wanted to deep dive into what this method or what this functionality is doing, I can do that, even if I'm not the one who wrote that code. I can go as deep as I need to better understand how my code behaves. Here, you can just continue to the next breakpoint, and these red dots are they're breakpoints, which allow me to specify places in the code that I want the code to stop. If I don't want to stop at any other breakpoints, I can press this one and it can mute all the breakpoints so the code just runs normally. And if I just want to stop the application from running without printing anything or emitting any results or stopping it in its tracks, I can click the stop button here. But I want it to finish, so I'll resume the program. And you can see here that I've printed out Charles says hello this many times. And I probably need a space right here or something. So Charles says hello this many times. Right, so let's put a space after says, and let's just run the program normally. And you see here, Charles says hello this many times. After that, because we are using Maven, we're also able to essentially go through the entire Maven lifecycle on the right hand side. So we can clean up the project, we can compile the code, we can package it, and then install it in our local .m2 cache. And we'll talk about those as well. So right now, if I clean, you'll see that all the compiled code goes into that target folder. And when I compile the code, or turning it into machine language, turning the human readable to machine language, you'll see that all of that code is generated, all the classes are generated here, and it follows the exact same structure as the application does up here. Let's see if we can look at the classes or the decompiled classes, and you can see that it changes my code just a little bit. A lot of it sometimes is for optimization, so the compiler will take care of that when we compile. Then you'll see the generated sources and all the annotations, and then some other Maven output. And then if we were to package this, you'll see that we'll get very different output down here. All of our tests will run. We have one test there, and it ran successfully. And it will create a jar. And this jar is essentially what we use to run the application. So you'll see when we start up the application that there are different ways to actually start it up. And then the installation steps. So if we want to install this on our local .m2, and say, for example, we wanted to build a small library of code that we wanted to use in other projects, it's accessible here in this directory. So this is users, my username, .m2 repository, and this is the jar that lives there. Aside from that, some other things that we'll be using later on, we'll be using the terminal. Since I'm on a Windows, I'll probably change the PowerShell to be more like the Linux terminal, so we can talk about some common commands. We looked at the debug screen. This is the run screen where we just were to run all of the Maven commands. And if we're using Git, which I probably should be, we could see the version control here and all the different versions of the code here. And if people like, we can actually cover Git basics as well, and go from basic understanding to advanced usage of Git, because it's a very important tool that allows us to work on different versions of our code at the same time, depending on what's being asked of us and what we need to do and accomplish. Intellij also allows us to look at the structure of our code. So if we go here into the greeting, you'll see that a greeting is consisting of a greeting builder, which is implied by this builder annotation, and these getters, which are also implied by these annotations. And then you'll see a greeting has an ID and a string. Oh, the other really important, and maybe the last thing that we'll cover for today, is actually how to start the application. So since I'm basically writing a Spring application, you can configure this application to run a certain way. And you can see here, I've configured the Java version. I actually need to change this to Java 11 because I want to use Java 11. And then this is the basically where my main method lives. You can see that this is the package com.odyssey.bookdo, com.odyssey.bookdo. And this is the class, the main class, because it has the main method that we want to run. If we wanted to add any arguments, we will put them here. If we build something more complex, we will. And then even environment variables. And then the directory, the working directory that we're in. There are other ways to start up an application, but we're just a plain old application right now. But you can essentially start anything that you want. Actually, this IDE is really powerful because you can use other languages as well. We might dabble in some Python. We actually will dabble into Dockerizing this entire application, and we'll talk about what that means and why we would want to do that and how it makes our lives a lot easier, especially when working with Spring and wanting to essentially build quickly and make our code more portable, because that's a really key functionality of Java. It's very portable. If you have Java installed on a machine, the code will run. And to even make it more portable, we'll put everything in a Docker container. I think we've covered a lot of ground today. We covered debugging, which is an essential tool and an essential practice. It's something that over time you get better at, and you understand where to find bugs and how to solve them. Finding them is always the hardest part. And then after that, we talked about Maven. We talked about all the different tool windows, which we'll become really familiar with as we are building out this application. Yeah. Thank you for staying this entire time, and I hope you learned something new. If you have any questions, just feel free to ask. Thank you.